Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor IARE, Hyderabad. Okay, in this video we will see problem of torsion bending constant, means to find the torsion bending constant, that mu. Right, so our lecture topic is problem of torsion bending constant, means how to find the torsion bending constant. Okay, so now let's see the question. A thin walled cantilever beam of length L, okay, has the cross section shown in figure. Right, so this is the cross section of the cantilever. That cantilever is back side, that having the length L. So this is of the cross section. Okay, carries a load P positioned as shown at its free end. Okay, that P is carried at the free end of that one. Okay, determine the torsion bending constant for the beam section. So now for this section, we have to find that torsion constant. So just see, this height is given as A by 2. This total height from this one, for this is what? 2A, and this is A, and this is A by 2. This is A. So this is just given in the figure. Now we have to find the torsion constant. So let's start. Okay. Initially the swept area, that again we have to find in that same shape. First we have to find the swept area. So what we are doing first, we are just assigning the number. So here, right, or just here. From here you just assign. Okay. So 1, 2, 3, 4, 5, 6. Okay. Now let's assign. Now what we will do, we will from the center of this we will take area, right, as we are taking, and now for that we will from there we will find. So just here. Okay. So from the shear center, that taken as what area, that as AR not, right, that is and as is acting in this direction. So from here the center is, because this total is 2A, so from this center it's A and this is A. Now just this plot or this curve we are plotting here. So now you see, just divided 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, depending upon the distance. 1 to 2, how much is there? A by 2. So 1 to 2, A by 2. 2 to 3 is given as A. So 2 to 3, A. 3 to 4, 2A. So 3 to 4, 2A. Right? 4 to 5, A. And 5 to 6, A by 2. So this is our actual one. Now just project this one. So now just see here, it's going like this and it's straight. So from here, 1 dash, 2 dash, 3 dash, 3 to 4 dash, it's a constant. Again 4 dash, 5 dash, and 5 dash to 6 dash. Right? So this is the area swept. Okay. Now just using the wire analogy and take moment about the S axis. Okay. So take moment about the S axis, like along this axis, because this is the S axis, right? So now just see. So from here 2AR into 5AT, right, into 5AT, that is equals to 2 into 3A by 2 into T into 3A square by 4, 3A by 2 into 3A by, into A by 2. So 3A by 4 plus 2AT into 3A square by T. So this is 2AR dash 5AT. Right. Now next, which gives from here, just find 2AR dash. So this whole divided by 5AT. So after simplifying, right? So here 2AR dash will give you what? 21A square by 20. Now we have the 2AR dash. Now let's find tau R. So tau R will be what? 2 into 3A by 2 into T by 3, because at 1/3 it's acting because of the triangular part. So into 3A square by 2 whole square plus 280 into 3A square by 2 whole square minus 580 into this one, right? A square by or minus 580, or you can say simply 2A square R, right? So minus 580 2A square 2A dash R. So minus 580 and 2A dash R is 21A square by 20 square. So after simplifying this, what we will get? Tau R as 1.25 into A power 5T. Okay. So now what we have? Tau R we have in terms of A and T, because the value is not given. So in terms of A and T only, the answer will be there. Now from the that bending this one. So we know that dq theta by dz is q minus mu square d theta by dz is equals to minus mu square by tjg, right? So this is the differential equation of third order, right? Where mu square is what? gj by e tau r. Now we have e tau, the tau r we found, right? So we can replace that one instead of mu square. So first is here. Okay, so and this we know that from d theta by dz. So d theta by dz is what? C cos mu h plus d sin mu h plus t by gj. Okay. So now here what we require to find the constant values. Okay. Sorry, here actually it should be C and D. Okay, C and D. So when Z is 0, wrapping will be what? W is 0, so that d theta by dz equals to 0. So put Z equals to 0 and d theta by dz equals to 0 from here. So from here, once we will put the d theta by dz 0, so that implies 0 equals to C cos h mu into 0 plus d sin mu into 0 plus t by gj. So this sin 0, 0. So this will be 1. So C will be equals to minus t by gj. Right. So now we have the value of C minus t by gj. Or simply if you want to take AB, then that form should be AB. Now second condition, when z is equals to L, the direct stress is 0. Therefore d2 theta by dz square 0. Therefore after substituting that, what happened? We will get the value of d as t by gj tan mu L. This or tan h mu L. This similar way already we found in the previous equation also. So that you can refer that also. Now just substitute the value of C and D here. So after substituting C and D, what we will get? Right. So just substitute the C value. So what we have? D theta by dz. D theta by dz equals to C, what we got? Minus minus t by gj, okay, cos mu z plus d, what we got here? T by gj tan mu L. So plus g by t by gj, not g by. So t by gj tan mu L, right? D into sin mu z plus t by gj. So now this equation becomes this one. So after that tan we can write in terms of sin by cos. Then just cross multiply and take LCM and simplify. So after simplifying, how to simplify this step that earlier also we discussed. So now, so that the rate of twist is what? D theta by dz equals to t by gj into 1 minus cos mu into L minus z. So first this will get converted to what? Cos A, cos B minus sin A, sin B formula, that cos of A minus B formula, right? Once you will break or just write tan h mu L as sin h mu L by cos h mu L, then take cross multiply. Okay, this after taking LCM, so this will be in denominator and then cos A, cos B minus sin A, sin B, that will give you the formula here. Okay, so now after simplifying that step, what we got? D theta by dz as t by gj into 1 minus cos h mu into L minus z by cos h mu L. Okay, now so just integrate this one. So after integrating, what happened? Just integrating this one, right? Tj by constant, integration of 1 becomes z, and integration of this, because mu L is constant, right? Only here the z is there, so this we have to integrate. So mu cos h L is constant, and integration of cos h mu L minus z is sin h mu L minus z, right? Into L minus z, differentiation of L minus z is minus, so that minus 1. So minus 1 and this minus becomes here plus, and plus C. Plus C is what? That integral constant, that constant of integration. Means again what we have to do? We have to find here what? The value of C. So for finding the value of C, we have to apply the boundary condition. Once we will find the value of C, then after substituting here, we will get the angle of twist. Okay, so let's find the angle of the value of C first. Then we will get, after substituting, we will get the angle of twist. So now the condition is what? When z is equals to 0, theta is equals to 0. Put here. When z is 0, right? Theta is 0. So 0 equals to t by gj into z is 0. So 0 plus sine h mu L minus 0 by mu cos h mu L plus C. L minus 0, simply 0. So what we can write? 0 equals to T by Gj into sine h mu L by mu into cos h mu L plus C. So this we can write out tan. So T by Gj into 1 by mu into tan h mu L plus C equals to 0. So C equals to minus T by Gj mu into tan h mu L. Now just substitute here this value of T. So after substituting, what we will get? So just here T equals to minus, okay, I'm just taking that term. So after substituting T, that minus Gj by T by Gj will be there. So that T by Gj is common here. Okay, so theta is T by Gj into Z plus, after substituting the value of C, sine h mu into L minus Z by mu cos h mu L minus tan h mu L by mu. Right? So now this is there. Now again what Z is there, that we have to remove the Z. So at the free end when Z is equals to L. So put here the value of Z as L. So what we will get after putting that? Theta equals to T by Gj into that Z is equals to L. So L plus sine mu L minus L by mu cos h mu L minus tan mu L by mu. So sine mu L minus L 0. So sine 0 0. So this term will be 0. Now what we have? Theta equals to T by Gj, right, into L minus tan h mu L by mu. Right, either you can write this one or take this L common. So from here this L becomes 1 and here that L is not there. So this will be divided. So theta equals to T by Gj L I'm taking. So here 1 minus tan h mu L by mu L. Right? So now here theta T, that theta, okay, is T L by Gj into 1 minus tan h mu L by mu L. So now we got theta. Inserting the given value in equation 1. Now just substitute where? Sorry, here. Okay, so now whatever. So T is what? 100 into 30, 30,000 Newton mm. J is 5 into 30 into 2 cube by 3, that gives 400 mm power 4 mu square. After substituting this, okay, what we will get? That mu square as 2.35 into 10 to the power minus 6. Just substitute the value, what is given here. Just see. Determine the torsion bending constant for the beam. Right. So from here, what we will get? Mu square equals to 2.35 into 10 to the power minus 6 and mu L as 1.53 and theta T from this, what you will get as 6.93. So just substitute the value, you will get the answer. Okay, so let me recall quickly. So just see 1 second. Now the question is what? A thin wall cantilever beam of length L. So this is just a cross section. This is not the cantilever. Cantilever, that back side is there. This is the free end of this one, right? Because cantilever should be fixed from the other side. So this is just a cross section of that one. L has the cross section. That's why it's written here. Cantilever beam cross section, right? Shown in figure and carries a load P, position as shown at its free end. Okay, determine the torsion bending constant that we have to find, right, of the for the beam section. So we are seeing this distance is given a by 2, a, this is 2a, this is a, this is a by 2. What we did here, we have taken the area, right, at 2ar. So here 2ar, S is acting along this, right. So after this, we drew this curve right? So from here 1 to 2 a by 2, 2 to 3 a, 3 to 4 2a, 4 to 5a, 5 to 6 a by 2, that is given. So according to this we plotted this curve for 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So from wherever it's coming, so here 2 is coming, so here 2 dash, 3 is here, so 3 dash, 4 is here, 4 dash, right? So this is area square of that 2AR naught. Okay. Now then using the wire analogy, taking moment about the S axis, right? This S axis. So after that 2AR dash into 5T, that must be equal to, because total is from here to here, that is 5. So that's 2A plus a 4A plus a 5A and a by 2 a by 2. So 5A into the thickness. So 2AR dash into 5AT, which is equal to 2 into 3A by 2 into T into 3A square by 4 plus 2AT into 3A square by 2, right? So this is moment about S axis. Now, so from here, after simplifying, what we will get? 2AR dash equals to 21A square by 20. Now, let's find the tau r. So tau r will be equals to, again just substituting the formula. So tau r is 2 into 3A by 2 into T into 1 by 3 into 3A square by 2 whole square, plus for the second part, this is for the 2 triangle, right? Now for the rectangle, so 2AT into 3A square by 2 whole square, right? Minus 580 into this 2AR dash, so 221 by A square by 20 whole square. After simplifying this, what you will get? Tau r equals to 1.25 e power 5 t. So now we have tau r. Now we know that dq theta by dzq minus mu square d theta by dzs equals to minus mu square t by gj, where mu square is what? Gj by e tau r. So now e, the tau r we found. G, j and e, that is required, right? So j also later we will find. So just see now, come to the angle of that rate of twist equation. So rate of twist is what? D theta by dz equals to what? C cos mu h plus d sin mu h plus t by gj. Now here what we have to do? C and d, or simply you can write here, by mistake in next slide I wrote a and b. So you can just take a and b or c and d. So now from after substituting, that means after putting the boundary condition, what will be the z equals to 0, d theta by dz equals to 0. So after putting that value, what you will get? A equals to minus t by gj. First boundary condition. Now second boundary condition, when z is equals to L, the direct stress is 0. Therefore, dq theta by dz square, that also equals to 0. Therefore, after substituting that, what you will get? B equals to t by gj into tan h mu L. Now substitute A and B value here, that is C and D value here, and simplify. After simplifying, what you got? D theta by dz is equals to t by gj into 1 minus cos mu into L minus z by cos mu cos h mu L, right? So from here, just integrate this one. So here integrating. After integrating, what we will get? Theta equals to t by gj. Integration of 1 by 1 is z, and integration of this is, because mu cos h mu L is constant. So integration of this is minus sin h mu into L minus z, and plus this integration constant c. Now here we have to find the value of c, right? Because integral constant is there. So to find the value integral constant c, again put the limits, right, or boundary condition. So when z is equals to 0, theta is equals to 0, which gives c equals to minus 1 by mu tan mu L. Now substitute the value of c. So theta will be equals to t by gj, okay, into z plus sin mu L minus z by mu cos h mu L minus tan h mu L by mu, right? So this is value of theta at the free end. So this t is for free end. At the free end, when z is equals to L, so put here z is equals to L. So this one, this term will be 0. So after that, t by gj, L minus this term will be there. Take L common. After that, you will get theta t equals to this one. Now from here, you can find the value of mu. Now t is what? 100. Load is given. So just see here the question. Load P is given. So just P into that you can write. Okay. J is this one. So mu square will be this one. After putting the value, mu L is 1.53 and theta tau is equals to 6.93 degree. Okay, so here this ends. So now finally all the videos of the analysis of aircraft chapter got over from this videos. So if you have any doubt regarding any video or any topic, or you can just comment on that particular video so that I can give the answer there itself, or you can just directly contact me, right? So just make sure to comment on that individual videos, right? Whatever you are checking in that, so whatever or wherever you have doubt. Okay, so for this video, you can comment on this video. Yeah, regarding any few doubt, I will clarify the doubts, or you can just contact. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.